Hello. Welcome to another lecture in research methods in psychology. Today I want to talk about quasi-experimental designs, and this is actually a really relevant topic right now here. It's April 23rd, 2020. We're in the middle of the COVID-19 outbreak. Lots of stuff going on around the world, and so we're going to talk a little bit about how some of this relates to quasi-experimental designs by looking at how we can compare across states and countries. So we're going to start off getting a hold on what a quasi-experimental design is, talk about some of the potential threats to the internal validity of quasi-experimental designs, talk about some threats to the internal validity of all studies that might be relevant, particularly to quasi-experimental designs, talk about threats to external validity, and then I finally want to finish up with talking about some specific types of quasi-experimental designs to consider. So let's start off with what is a quasi-experimental design. Sorry, I'm having a hard time with my mouse today. These are essentially experiments that are conducted out in the real world. They have characteristics that are a lot like true experiments, with procedures that resemble true experiments, some of them, not all of them. We're going to talk, for example, about studies in schools. Oftentimes these are quasi-experimental designs where we'll test out some sort of pedagogical innovation in one class versus another. These are quasi-experimental designs because oftentimes we can't randomly assign people to different classes, and we don't have as much control as we might like to in the laboratory, but we have a treatment intervention and a comparison. So for example, Mark McDaniel at Washington University outside of St. Louis has done a number of quasi-experimental designs in classrooms looking at testing effects and other types of innovations in trying to improve learning in schools. And so they go out to schools and test these innovations that they've had in the lab and see if they work out in the real world. So oftentimes these are laboratory studies that are then taken out into a quasi-experimental design. But they lack the control of true experiments. Obviously, if you're in a school, you can't have control over everything. You can't control who's going to be in which classes, who shows up on what days. There's a lot going on. So you have to try to measure so you know exactly what's been happening. So why do we use this instead of a true experiment? Well, oftentimes it's difficult to conduct true experiments. We'll talk about some ways in which that is going to be the case. So for example, to get out of schools, if we are interested in trying to study the effects of changing the speed limit on traffic accident deaths, can't do that in the lab. I mean, we could probably could start with driving simulator studies, but we really need to go out in the real world. And in fact, there's a lot of this that you can do. You can look at before and after the speed limit was raised and lowered in the United States, or I should say lowered then raised again. And you can also look at lots of other potential types of real-world interventions. So a lot of times getting access to participants is a little bit easier in these kind of quasi-experimental designs than it might be in a genuine experiment. We try to use random assignment when possible, but it's not always available. So I know in some instances in schools they've been able to go in and randomly assign kids to classes to who's going to get which intervention. So it really makes them much more like an experiment. So we use that when possible, but it's not always available. So we're going to run through quite a few threats to the internal validity of quasi-experimental designs. There are a number of things that can influence the potential validity of a quasi-experimental design. So a moment ago I was talking about traffic accident deaths with raising and lowering the speed limit. We're talking about history effects, and one of the things that might happen in those instances that interferes with your study is changes in technology. So, for example, cars have seatbelt laws have changed. Cars have airbags. Cars have much greater safety features than they did in the 70s when the 55 mile an hour speed limit was first started and then dropped later on. So there are other things that are happening at the same time that you have to consider. So that's the kind of threat to internal validity that we're going to talk about. Let's start off with history. This is the occurrence of an event other than the treatment. So in true experiments, this is solved by just having strict control over conditions. But when we're talking about getting out into the real world, lots of things can happen. And what's really important is trying to consider whether or not it's directly relevant to our question of interest. So if you were studying anything this year out in the real world, it's all COVID-19 right now. So that's a huge history effect. And in fact, we're going to talk about how COVID-19 is having an effect on a number of data points that are particularly interesting. So for climate researchers, wildlife, lots of things going on that we can talk about as being a history effect. That creates an opportunity, but also has a problem. Obviously, I'm not trying to say this is a positive opportunity, but there are things we can learn while we're in this particular crisis. So again, often these events are turned into research questions. There's an avalanche of research following the September 11th terrorist attacks. Again, I think the important thing here is to understand how directly relevant it is to your research question. So we talked about things like improvements in technology and car accidents and car deaths. Other things can include, for example, if you were interested in studying, let's say you've come up with curriculum to reduce bullying in a high school, and part of that curriculum is on acceptance of sexual minorities, gays, lesbians, transgender individuals, etc. And, a very popular kid at the high school comes out. That's a history effect that's relevant to your question. And so there's something in that you just have to be mindful of what's happening around you. So these things can happen. They happen all the time. Maturation is another question. This is particularly irksome for developmental psychologists or people that are studying behavioral effects in kids that are growing up, because participants do change as a function of time. They mature. So if we're looking at the beginning versus the end of the school year, it's possible the change in your dependent variable. So again, if we're talking about some kind of intervention in a school, again, maybe about bullying, it could be the kids grew up. So we want to think about how a couple things might be happening. One of the things we do in these instances is we use a pre and post design, of course, but because some of that might be maturation, we have to consider that. So we might want to use a comparison group that did not get the intervention. So that's going to help us determine whether or not potentially maturation could be a problem. Now I have on here differential maturation can be a problem, and this is particularly problematic when you're looking at sex and gender in adolescence, because girls mature faster. They get taller faster. If you measured everyone's height at the beginning of the year and the end of the year in an 8th grade class, girls are going to shoot up quite a bit at that age. Somewhere around 6th to 8th grade, girls just all of a sudden start growing a lot faster than boys do. It's simply a fact of life. So you have to think about that and think about how maturation might be in effect. Testing, this is a huge thing right now. A couple things going on. Taking a test has an effect on subsequent testing. In fact, we know testing is a form of learning, so we have to be careful with pre and post testing. And in this case, I'm really talking about testing abilities. So we have to think about whether or not participants have had alterations in their test performance simply because they took a previous test. So these pre and post tests are a good design, but again, having a comparison group with pre and post is probably the best way to go. Instrumentation, and this is where we're really having an issue across the country. So changes can take place in the instrument being used to measure performance or to measure anything. Usually in psychology, we're talking about performance. This is particularly troublesome when there's a change in who's doing the measuring or the type of measurement being used. So for example, we'll start with something simple, benign. If we're using employee evaluations as a measure, but the supervisor who's conducting the evaluations changes, that's a problem because obviously we have completely different person doing the evaluations. Right now, we have a lot of issues with instrumentation in antibody tests and in tests for COVID-19 coronavirus presence. So, interestingly, I actually had a conversation when this first started with an infectious disease doctor who was from Seattle, Washington. She was actually headed back to the hospital where they had their first outbreak. And the test for COVID-19 at that time, and most of it at this point too, is a nasal swab that requires some pretty challenging examples. And if you have a strong stomach, go online and watch one of the videos of this being done. I mean, it's not cute. I'll just say that. So the collection procedures for those tests are often a part of the issue in the number of false positives and false negatives, particularly the false negatives. Now we're on to antibody tests. And as you know, I posted a lecture on antibody tests and signal detection theory, and a lot of work moving forward in that. I read this morning there's about a 2 to 3% false positive rate in antibody tests. It's pretty high, so we have to think about those antibody tests, and as they change, they'll get better, and so that instrument will change over time. And so one of the things we have to be mindful of at this time is increases and decreases in caseloads oftentimes have to do with the instrument that's being used. We also have to think about the background number of tests being done. And these are all really important considerations that have to do with this question of instrumentation and the rate of instrumentation and the rate of testing. A really difficult time to get a handle on all of this data because the data just is noisy. It's not very good. You should follow Nate Silver on Twitter. He talks a lot about noise in the data. So a decrease in cases one day or even 2 days isn't a trend. So one of the things you want to look for is a trend line. Okay, I'm wandering off topic, but let's get back to our threats to internal validity of quasi-experimental designs. One of the things that oftentimes students have this is one of these concepts that students often have trouble with. This is a question of probability, and it's what we call regression towards the mean. Y'all remember the normal curve. So when we are selecting subjects based on extreme scores, or subjects who, in whatever study we have extreme scores, the next measurement is likely to be less extreme by simple probability. Okay, so one of the things we always have to assume is that when we sample a distribution, so we sample a population, and we pick an extreme sample, the next one is likely to be less extreme. Simply because if you look here at the normal curve, over here at the far right, we have the very little area underneath the curve. So for selecting people with high verbal ability, or if we go out to the left end here, very low verbal ability, okay, so we've tested them, we get low verbal ability. If we test them again, their scores are likely to be closer to the mean. That is, they're likely to improve if they had bad scores, and they're likely to get worse if they had great scores. This is just simple probability at work, and this has nothing to do with really anything but probability, and that's one of the things that's really important to understand. So if we decide we're going to intervene with participants who are having very low verbal ability scores, and then we test them again, their scores are probably going to improve if we had done nothing. And this is where, again, we have to start thinking about some of the research being done on COVID-19 patients, because oftentimes we're talking about interventions with the sickest patients. So we have to start, eventually we'll get there, thinking about research involving people who are not the sickest patients, because those patients are already sort of likely to die. And there's some articles that came out recently about the malaria drug being used by the VA, and they found a higher death rate with those who were given this particular drug. It's possible the drug was causing that, but it's also possible that they were only giving the drug to the sickest patients. So this is the reason why we have to have randomly assigned placebo-controlled designs in drug trials. We're doing quasi-experimental designs in cases where we need to do experimental designs. And that's really important, getting the science right. So this all has to do with where people are kind of in this distribution. And they're just simply more likely to be closer to the mean in their next measurement. So that's kind of where we're at. All right. Attrition. Another problem with these kind of experiments. This is particularly problematic if it's systematic or related to the intervention. And so we might go out into the community and enroll, let's say we're going to enroll older adults in some programs to improve their health and their cognitive abilities. So we're going to assign one group to do some light gardening. We're going to assign another group to do some pottery, and then we're going to assign another group to aerobic fitness and weight training. I don't think it's any stretch for you to think about that some of the aerobic and weight training participants might drop out, and probably at a higher rate. So we might end up with a significant difference, a significant improvement in the weight training and aerobic conditioning group. But we also have participants left over in that study who are probably pretty resilient and also very much liked that particular intervention. So you have to watch out for this kind of systematic attrition. Always we have to worry about selection bias. So between groups differences exist from the outset of a study. We have to think about that. This is where we have difficulties with a lot of the data in COVID-19 studies because people are getting tested are more likely to be symptomatic. We don't have broad-based testing. We have to think about the tests themselves and whether or not they're functioning correctly. So lots of selection issues going on there. So one thing that's obviously an important question right now is if we're interested in studying the pedagogical efficacy of online versus in-person teaching. And in general, the studies that have been done in the past don't find much difference. The problem is people sign up for online courses because they like online courses, and people sign up for in-person teaching because they like in-person teaching. Right now, we're in the middle of this massive experiment with taking a bunch of people who wanted to do in-person teaching and throwing them into an online course. It's a huge problem. And it's a selection bias problem with professors as well. People teach online courses because they think they can do it well. People teach in-person classes because they can think they can do that well. So there's a huge selection bias problem going on in this massive quasi-experiment we are all living. Okay, some threats to the internal validity of all studies. First is contamination. This happens where you get some communication of information about the experiment between groups of participants. So let's say I've come up with this really nifty way to learn biology. And so I go to one introductory biology class on a college campus, and I use this nifty study intervention, study tool to teach them biology. Well, now let's say a couple of girls from a sorority come home with this nifty study technique, and some of their sorority sisters are in one of the classes that didn't get the study technique. Well, now they've got it because that's somebody's come home with it and they've contaminated the use of that nifty study technique, and it might look like the study technique didn't work because of contamination from that other class. Experimenter expectancy, of course, lots of this going on in quasi-experimental designs. We find an effect because we expect an effect. We read the data in certain ways. We have effects, we might interact with one group or another depending on the kind of design. So these are important things to think about. The Hawthorne effect, there's lots of question about the Hawthorne effect and whether or not it's genuine. And this is named after a study where they went into a factory and found that if they closely supervised people, they worked harder. Well, it's not really that surprising. But the idea is you get a change in behavior because people know they're being observed and they're being paid attention to. There's some belief that if you ask people how they're doing, that'll improve their performance. There's a lot to this, but certainly we know that there are observation effects. When people are being observed, their behavior changes. There's nothing surprising about that. So threats to external validity, all the same ones with the experiment. Do we have a representative population? Does whatever we're doing generalize outside of the experiment? Does the situation itself generalize? We're in the middle of this huge experiment on online teaching that is not going to generalize to anything else because this is so unique. So you have to think about the situation. The best test of external validity is in replication, and let's hope to God we don't have to replicate this current experiment. I don't want to do it again, and none of you want to do it again. So the best test of external validity is to replicate, so we just do it again at a different school, different group of people, different test, etc. All right, so we're going to finish this out with specific designs. We'll talk about non-equivalent control groups, interrupted time series, and time series with non-equivalent control group. So this is an interesting area as well. So a non-equivalent control group design, a comparison group is selected on a basis other than random assignment. And this is kind of what we've been talking about with, say, we have two classes. So we're going to just assign a certain study technique to one group but not the other. Okay? So it's not random assignment. So the first thing we have to do is we can't assume that the groups are equivalent. We may want to do a bunch of measurement at the beginning to see if everybody has similar verbal abilities, similar IQ, similar whatever. So we also want to use a pre and post test design between both groups, so we see if one group improves more than the other. We have to use at least comparable groups, right? We can't take an 8th grade class and compare it to freshmen in college. Can't do that. Got to use comparable groups. We can eliminate some of those confounds, history and maturation, because we're comparing those groups, and I mentioned that a little bit when I was talking about these confounds. Interrupted time series designs, welcome to our world. Researchers observe changes in dependent variables for some time before and after a treatment is introduced. And this requires pretty sharp changes in whatever our dependent variable is. So we can look at things like traffic fatalities before and after a speed limit change or a change in drinking age. The other thing we can actually do is what's called an AB design, where we can add the sort of treatment, as we say, and then take it away. So there's an interesting study on crime in which they introduced a police helicopter to a neighborhood. Crime dropped. They took the helicopter away. Crime went up. Brought the helicopter back. Crime went down. So that's that kind of AB design that we're talking about. We're right in the middle of some of these as well. So we're in Colorado. We're under a stay-at-home order that ends at the end of the week. So we're going to slightly remove that intervention, and it may come back. So we may have to reinstate that stay-at-home order based on available data. So the dependent variables, interestingly, that they're looking at here are mobility data based on people's cell phone data. So they're able to track, Google and other companies are tracking how close you are to other people's phones, how often you're visiting stores, etc. So we want to try to maintain 65% social isolation or social distancing. So we'll see how that goes. The other dependent variables, of course, are going to be hospitalizations and deaths. And so we kind of want to watch for changes in those dependent measures. Some interesting other interrupted time series designs that are a part of this pandemic, both in lots of places. There is a dramatic change in air pollution, and this is probably even more dramatic. This just compares March 2019 to March 2020. You can see lots of reductions in pollution across Italy because, of course, they were in a pretty major shutdown. If you look in lots of major cities, LA, the air is cleaned up quite a bit. Here in Denver, the air has really dramatically improved. So I'm guessing we'll probably also see lots of improvements in asthma and other respiratory difficulties because of this shutdown. So there are lots of different kind of variables that you can look at with this kind of interrupted time series, where we have kind of stopped a bunch of things happening. So if you look, for example, at wildlife behavior, another good example in Yellowstone, bears are apparently a lot more bears than they realized because they're not shying away from humans and all that traffic that's in Yellowstone. And so they're actually coming out quite a bit. You can see jellyfish in the canals in Venice. So there's lots of things that are happening in wildlife biology right now that are pretty interesting. Obviously, we'd rather not have to do it because of a pandemic, but pretty interesting designs. Finally, we have time series with non-equivalent control groups. So basically, we're going to combine our two methods. So it's similar to an interrupted time series design, but we have a similar group without an intervention that is used as a comparison. So to use a simple example, we might look at different states where one where the speed limit is lowered and another where it stays the same, or one where it's increased, another where it stayed the same. You obviously want to try to find two states that are as similar as possible in terms of weather, in terms of proportion of interstate highways. I mean, there's a lot of things you would have to think about in terms of looking at this kind of quasi-experimental design. Right now, we're in the middle of a pretty dramatic time series with non-equivalent control group designs across countries and states because of different quarantine rules and different stay-at-home rules and different social isolation rules, what businesses are allowed to be open. And so one of the things you can do is you can look at the differences across those states. And I found this really interesting graph in the Midwest. Importantly, and this is really important when you're looking at graphs from this particular pandemic, is very often they are using numbers, raw numbers, and not proportional data. And in this case, they're using proportional data because you can't compare North Dakota and Wisconsin. They have wildly different population sizes. So if we used raw numbers, this graph would make no sense. So we're looking at deaths per million residents. And I'm not sure, I haven't had a chance to look at what the difference is in Wisconsin compared to these other other states. I know Minnesota has some pretty strict social distancing rules at the moment, but pretty dramatic. Of course, we would have to also think about what other differences there might be. Is the Wisconsin population, is it possibly more elderly? Are there other issues like that? But I think this is a good example of this kind of interrupted time series design with non-equivalent control groups. So looking at these interventions, we're going to be looking at a lot of these kind of graphs and trying to see what's working and what's not across different states and countries. So I want to conclude a couple things. These are, troubling times, but they provide us with an opportunity to learn about human behavior. More importantly, these designs can help us improve our responses to this particular crisis. And so we can actually use this kind of non-equivalent control group to make comparisons about what's working and what's not working. So for example, here in Colorado, while we obviously share a number of borders, Denver itself is pretty far from Kansas. It's pretty far from Wyoming. It's pretty far from New Mexico. It's very far from Utah on the west. So because people are kind of staying at home, we can really probably get a pretty good handle on what's happening in, say, the city of Denver compared to other cities like, for example, Kansas City and St. Louis. There's a huge problem because both of those large cities in Missouri are straddling state lines. So half of it's in Kansas and half of it's in Missouri for Kansas City, or for St. Louis, part of it's in Illinois. So you really have to think about these things very carefully. I also want you to think about ways in which to get out of the gloom and doom of pandemics. There are a lot of examples about how we can improve our cities and urban design using quasi-experimental designs. So if you look around, there are places where you can look at bike lanes have been put in or taken away, put in and taken away. Different types of bike lanes are put in. There's lots of quasi-experimental designs being done with that, with bike safety, with pedestrian safety. Denver's doing a lot of this right now. And so there's a lot of ways in which these kind of designs can be used to help improve the human condition. And I think those are really important to think about. Anyway, Hope you all learned something and have a great and safe day.